There's a place on Earth darker than outer space, and you don't need a rocket to get there. You just need to go down. That's the part that should stop you cold. Space, the thing we picture as the ultimate darkness, the emptiness between galaxies, actually has more light drifting through it over long stretches than the deep ocean floor does. So how does water, something you can see straight through in a glass on your kitchen table, turn into a wall so absolute it outdarkens the entire universe? Let's deal with the assumption first, because I think you're carrying one around without noticing. We call space the void. We picture it as nothingness, total black, the absence of everything. That's not quite right. Space is faintly full, starlight scattered in every direction, ancient photons left over from the Big Bang, still drifting through as background radiation, the dim glow of countless distant galaxies. It's dim, almost unimaginably dim by our standards, but it's not zero. Nearly anywhere you point in space, there's some photon passing through, however sparse, however old, however faint. The ocean floor, past a certain depth, has none. Not faint, not rare, none. So what's actually killing the light on its way down? Here's the mechanism, and it's more elegant than you'd expect. Sunlight isn't one thing, it's a mix of colors, and each color carries a different amount of energy, and water absorbs each one at a different rate. Red light, the lowest energy color, gets eaten first. It's gone within about the first 15 meters. That's why, if you cut your finger diving near the surface, the blood doesn't look red anymore. It looks gray, almost brown, because the red light that would normally bounce off it and reach your eye simply isn't there to bounce anymore. Orange goes next, then yellow. Green and blue hang on the longest, which is exactly why the ocean looks that deep sapphire blue near the surface. That's not decoration, that's genuinely the last color standing, the final survivor of the fight. But even blue, the toughest of the bunch, is completely gone by around 1,000 meters down. Past that depth, in what's actually called the midnight zone, there is no sunlight, not a trace, not on the brightest day of the year, not ever, regardless of what's happening on the surface far above. Now here's the real distinction, the one that reframes this whole comparison. Space is dark mostly because there's almost nothing out there to interact with the light. It just keeps traveling uninterrupted for billions of years, occasionally landing on a detector or an eye. The darkness of space is a darkness of distance, of sparseness. Nothing's in the way. There's just very little light to begin with, spread across an almost incomprehensible amount of empty room. The ocean's darkness is something else entirely. It's a darkness of absorption. Water molecules are actively grabbing photons out of that light and converting their energy into heat, one photon at a time, relentlessly, for every single meter the light tries to push downward. Two completely different mechanisms, arriving at the exact same experience for your eyes. Nothing to see. One is emptiness with nothing there. The other is a substance, actively, continuously erasing what was there a moment ago. So if no sunlight reaches down there at all, why isn't the deep ocean actually completely empty of light? Here's where it gets good, because sunlight can't get past 1,000 meters sounds like the case is closed, and it isn't, not quite. The deep ocean is riddled with bioluminescence, creatures generating their own light from scratch through chemical reactions happening inside their own bodies. Flashes, glows, pulses drifting through total blackness, an entire light show running in complete isolation from anything the sun ever provided. And we understand the chemistry behind that glow with real precision. The enzyme reactions, the specific molecules involved, we can practically write it out on a whiteboard. What we don't fully understand even now is the scale of what that light built. How many species depend on it? How many behaviors? How much of an entire evolutionary economy down there runs on light that never once came from a star? Light manufactured entirely by the animals themselves in a place where the sun might as well not exist. We've mapped the mechanism. We haven't mapped what it grew into. And here's a fact that should genuinely recalibrate how you think about this planet. That sunless part of the ocean, the midnight zone, isn't some small exotic corner. It makes up more than half of the entire volume of habitable space on Earth. Not half of the ocean, more than half of everywhere life could possibly exist on this entire planet. Oceans, land, atmosphere, all of it combined. We live on a world where the single largest living space isn't a forest, isn't a coral reef, isn't even the sunlit surface of the sea. It's a darkness deeper than the one between the stars. And most of us will go our entire lives without ever once picturing it. Which brings me to the thing I actually want you to walk away with, because I think it's bigger than the fact itself. We grow up treating darkness like it's one single thing, an absence, a lack, the same nothing no matter where you find it. But this whole comparison shows that isn't true at all. The darkness between galaxies and the darkness at the bottom of our own ocean are built by two completely different processes, arrived at through two completely different histories, and yet they hand you the exact same experience. Nothing to see, nowhere for your eyes to land. Darkness was never really a single thing. It's just the name we give to wherever light happened to run out, whether that's after crossing billions of years of near-empty space or after struggling through less than a mile of our own water. And maybe the strangest part of all isn't that the ocean floor is darker than space. It's that something this close, something entirely of this earth, something you could theoretically swim down into yourself, given the right equipment and enough nerve, turns out to be a stranger, darker frontier than the one we've spent decades pointing telescopes at. We keep looking outward for the edge of what's knowable. Sometimes it's directly beneath our own boats, a few thousand meters down, in water we've been swimming in our whole lives, without ever once wondering what happens to the light.